All right. So one of the properties of the functions is AND behavior. The AND behavior of a function f describes the behavior of the function at the ends of the x-axis. Okay. In other words, the AND behavior of a function describes the trend of the function if we look at to the right end of the x-axis. So this is as x approaches positive infinity, and to the left end of the x-axis as x approaches negative infinity. Okay. So let's look at the first example. Make sure you put arrows here so that is forgotten. So as x approaches positive infinity, so we make x larger. Okay. So what is happening to the y values? As x gets bigger and bigger, y gets negatively large, right? When x is, let's say, here, so you have negative big y value, but we are thinking that as x approaches positive infinity. So as x approaches positive infinity, it looks like y approaches negative infinity. So that is the right end of the graph. How about left end of the graph? As x approaches negative infinity, okay, so as x gets negatively large, what's happening to the y values? Look at this, right? So y is getting positively large as well. So y approaches positive infinity. And when you are looking at the AND behavior, we don't care what is happening in the middle of the graph. We only check very right end and left end of the graph. We don't care what's happening in the middle. Okay, so let's look at the next example. Okay, so we are going to check as x approaches positive infinity and as x approaches negative infinity. So as x approaches positive infinity, what's happening to the y values? Let's say when x is 4, or when x is 3, y is 2. When x is 4, y is 1.5. When x is 5, y is 1.2. When x is 6, maybe 1.1. So what is happening to the y values? They get closer and closer to 1, right? So look, here they say 1.1. Maybe when it gets bigger and bigger, the y values are going to get, let's say, 1.01, 1.001, 1.00001. So y values are getting closer and closer to 1. So y approaches 1. Okay. Look at the other side, left hand. So let's say when x is negative 1, y is 0.8. When x is negative 2, 0.9. When x is maybe negatively large, 0.9, 0.99, 0.9999. So again, y values are getting closer and closer to 1. So y approaches 1. It is not 1. It never touches 1, right? It is never 1, but it is getting closer and closer to 1. So therefore we say y approaches 1. Okay? So if there is a horizontal asymptote, maybe one end or both ends are approaching to that horizontal asymptote, right? So that is one of the properties of the functions. What are the other properties of functions? Domain and range, continuity, discontinuity, so asymptotes, right? And behavior, x and y intercept, intervals of increase and decrease, symmetry, even or odd functions. So those are some properties of functions. So let's look at the example 1. It says state the equation of a function with the following characteristics. State if the graph is continuous. Okay. So there is a vertical asymptote at x equals 2 and horizontal asymptote at y equals negative 3. So we are going to write a possible equation for this function. Okay. There is more than one answer, but we are going to write one possible. All right. So what kind of function is that, first of all? So there's a horizontal asymptote and a vertical asymptote. rational function. Okay, so we figured that out. All right, then how can I use this information? There is a vertical asymptote at x equals 2. How I am going to use that information? Maybe 1 over x minus 2. That would give me a vertical asymptote at x equals 2, correct? Now let's use this other information. There is a horizontal asymptote at y equals negative 3. Right? Horizontal asymptote originally at y equals 0. Now it is at negative 3. So there is a vertical shift 3 to down, right? So then it's the c value. So you put it here. Well, this is only one possible answer. How about if I do this? Is this okay? Negative 1 over x minus 2 minus 3. Does this satisfy these conditions? Right. So it satisfies, right? Because there is still a vertical asymptote at x equals 2. There is still a horizontal asymptote at negative 3. How about if I do this? 5 over x minus 2 minus 3. Is this possible? Yes, it is possible. But of course, you want to write as simple as possible, but I just wanted you to see that there is other possible answers. Okay? So let's look at the next one. The range is given from negative 5 to 1. So again, think of the functions that you know. What kind of function this could be? The range is limited from both sides. What kind of function is that? Is it a parabola? Is it a line? Yes, it's a trigonometric function. Correct. So if we sketch it, okay, so maximum is 1, minimum is negative 5. Alright, so this is the only given information. So this could be a sine function or a cosine function. We don't really even care about that because, okay, so let me do this. Doesn't matter what it is. Okay, so if this is the case, what do I need to know from here? I need to know the axis, the equation of axis. Okay, so equation of axis or axis is the line that goes in the middle compared to maximum and minimum. So then what is going to be the equation here? So in total, from maximum to minimum, it is 6 units. So this is going to go halfway. So it should be 3 units from maximum or minimum. Okay, so that gives us y equals negative 2. What else you need to know? The amplitude. Okay, so amplitude, the vertical distance from axis to the maximum or minimum. So amplitude in this case, right, if this is negative 2, that is 1 to 3 units. So amplitude is 3 units. Based on that, let's write one possible answer. So first of all, let's write the one that I draw here. So what should I use? Amplitude is gonna be 3 for sure. Should I use sine or cosine? Cosine. Let's use cosine. Okay. X. Then negative 2 should be at the end, right? And because I started from the minimum, so I put a negative sign. That is one possible answer. Okay. Let's write other possible answers, which is not going to match with the one that I have here. Okay. But can it be 3 cos x minus 2? Yes. Can it be 3 sin x minus 2? Yes. Right? Even you can have different period here or different phase shift, doesn't matter. They will still satisfy this condition. Right? So let's look at the next one. interval of increase is from negative infinity to positive infinity. Okay, so this means that the graph is increasing at all times. And there's a horizontal asymptote at y equals 3. What kind of function that could be? Think about the ones that you already know. Rational function, trigonometric function, square root function, exponential function, parabola, line. What can it be? Exponential function, right? Okay, so looks like I'm going to sketch it first. So there is a horizontal asymptote at y equals 3. And the function is always increasing. So that is one possible graph here. Okay? So what could be a possible equation? Y equals the base. Does it matter? Not really, right? But as long as you have one with because it is increasing at all times, it should be greater than 1. It is increasing. It is an exponential growth. So let's say 2 to the power of x. And the asymptote is at y equals 3. So 2 to the power of x plus 3. Can I do 5 to the power of x plus 3? Yes. Can I do 10 to the power of x plus 3? Yes. Can I do negative 2 to the power of x plus 3? Can I do this? If it is negative x, if there is a negative sign in front of it, so that's a value. A value does reflection over the x-axis. So instead of this, I should be getting that. But that is not increasing at all times. It is decreasing. So that's not going to work. Okay? This is not possible. How about if you had this? So when you try to write it again, you want to pick a one that is the most simple one, right? You don't want to really write something that is complicated. But how about if it was like this? Is this graph okay based on the given condition? There is a horizontal asymptote at y equals 3, and it is increasing at all times. Okay, so it looks like this is fine. So how can I write a possible equation for this? So if the graph was like this, if it was decreasing at all times, well, let's say y equals 1 over 2 to the power of x. Right? That is decreasing at all times. If I reflect it over the x-axis, then I would get that. So y equals negative 1 over 2 to the power of x plus 3. That could be also a possible answer. But again, you know, when you're writing it, just do the most simple one, right? So this one, this. Let's look at the next one. Domain is given greater than or equal to 0. Range is given y greater than or equal to negative 2. Okay? So what kind of function that could be? What kind of function that could be? Domain is limited, restricted, and the range is restricted. Square root function. Exactly, right? So x is 0, y is negative 2. Okay? So it's x greater than 0, y greater than negative 2. So it's going to be looking something like this. Okay, let's write a possible answer for this equation. Y equals root x minus 2. There you go. Can I do negative root x minus 2? no, the negative root x minus 2 would look like this, then the range is not okay, right? Okay, this is not good. How about, can I do 3 root x minus 2? Yeah, that's okay, right? Or I can put maybe some k values there, but I should not be putting any d value, so there is no horizontal shift or reflection in this case. Alright, so let's look at example 2. Sketch a graph that has the following characteristics. It is odd, it is continuous, it has zeros at -3, 0, and 3. It is increasing from negative infinity to negative 2 or 2 to infinity, decreasing from negative 2 to 2. So I'll give you maybe